I'm Patrick McHugh with AWS, US Southeast Latin American sales leader. Can y'all hear me? Can someone put in the chat that you hear me? See, is this working right? All right, you can hear me. Great. I'm here in Atlanta. So Timothy Brown, I see you. Good morning from Atlanta. Braves up 3-1. Hopefully we can close it out tonight against the Dodgers out in LA. So good morning after you have an echo? Hopefully you're just echoing Go Braves. That's what I'm hoping you mean. So good morning. I'm here to talk a bit about why cloud is a great enabler for analytics and a brief overview of how AWS is enabling analytics at scale. So a customer of ours, an AWS customer, recently wrote a blog, and I saw this line that really struck me. It says, if everything you're trying is working, you're not thinking big enough. That's an interesting sentiment. We all want to succeed, obviously, but if you're not failing, you're not trying. But it does imply that the cost of failure is relatively low. It does imply that the speed at which you can experiment and fail is relatively low, because then you can recover and try again and try again and try again. So that's certainly an issue it's certainly a goal of innovative companies. It's one of, actually, we don't have a leadership principle that explicitly says it. We certainly have invent and simplify as an Amazon leadership principle, but I really like that. So how do we try harder? How do we think big? How do we fail faster and experiment? And how do we make a difference in our customers and in our world with analytics by trying harder, thinking bigger, failing, but then succeeding faster? So I'm going to tell a couple of fascinating stories of companies who have experimented and made big differences. So the first I'll talk about is Novartis. Novartis is a pharmaceutical company. Many of you have heard of them, of course. And this story is a little old. This story is actually from 2013, but to me, it still encapsulates experimenting boldly, trying and trying things that otherwise may not have been possible. So Novartis was looking for cancer-fighting drugs. They were doing something called computational chemistry, which is basically mathematically simulating certain drug compound interactions. And they wanted to go run this test. And they felt, and this was 2013, they felt they needed 50,000 cores of compute that would have cost $40 million to do the analytic, to run the test. So the first challenge is $40 million is a lot of dollars. Even at a pharmaceutical company, $40 million is a lot. Secondly, it probably would have taken months and months and months to get it approved, the equipment manufactured, installed, and run the test. But then, do we know it would be successful? If I'm a VP asking for $40 million, do I know that this $40 million would have paid off? Well, no, that's the point of research. You don't know. So that's a pretty big bet. That's $40 million, all that time. I may think of, I'm not even going to try because it's so big. It's such a big thing. And if I screw this up, this is career limiting move right here. Well, they happened to hear about this thing called cloud at the time. And they also heard about this thing called spot market. And the spot market is basically like a price line for airlines. Spot market says, I don't need the compute right now. I can use it later today, later this week, maybe next week. I'm flexible, just as long as it's before the 6 months it would have been otherwise. So I'm flexible. And because of that flexibility, I'll give a lower rate. So they tried the spot market. They tried the test. And so the first question I have, and let's just put it in the chat directly. So when they leverage cloud in this spot market, and the test actually ran in 9 hours, I believe it is. The stats are public. So it ran for 9 hours. What do you think the cost was? So $40 million is what on-prem 50,000 cores would have been. What do you think the cloud cost at spot market was to run this test instead? Put it in the chat. Let's see some guesses. If it wasn't 40 million, what do you think this test actually cost? I need to see some answers. Tim Brown, Atlanta, let's hear it. How much do you think the Braves would pay to run this test? I need a number. Okay, I see $1,000. I see a heart. Okay, hearts are priceless. Way lesser, $4,000. Okay, Nancy McCormick is the closest to the pin. It was in fact, $4,232, for which would have been 40 million was $4,232, which is, I think it's 20,000 or 1/100th or 1/1000th, a lot less. Let's go with a lot less. So, and they did in fact find three chemicals. They found three chemicals, that could fight this type of cancer, which to me is just the amazing story that if because of enablers like cloud, you can experiment boldly. The cost of failure is only $4,000. The cost of failure is not 40 million. And we're getting it done faster. How many lives were saved because we didn't have to wait the 6 months or just didn't even try? So I find that as a great example of thinking big, trying hard, and in this case, ultimately successful. So to continue on the pharma theme for a moment, next poll question: how long on average? Yeah, exactly. The VP of that company saved $40 million and found cancer-fighting chemicals, for the families of loved ones who are now saved because of these pharmaceuticals. They certainly thank them as well. Next question. Let's talk about Moderna. So another question, put them in the chat. How long on average do you think it takes for a drug to get approved by the FDA, the United States Food and Drug Administration? I know we have some international folk here. So how long on average do you think it takes for a drug to get approved by the FDA? Three months. Whoa, you are way optimistic. Nancy, okay with 5 years? Okay, anyone else? 2 to 10, 1 to 5, 5 to a year, 2. It's actually 10 years. 10 years. 10 years is the average time it takes to get a drug approved. Well, guess what? COVID came. We didn't have time for 10 years. We needed some solutions in pharmaceuticals faster than that, of course, much less than the 10-year average time. So Moderna is, as you know, one of the three main vaccine providers now: Moderna, Pfizer, Johnson & Johnson. Moderna has always done, they're a startup out of Boston. They've always done their research. They've been cloud native from the onset. And in 2019, obviously, they didn't have a capacity plan for doing the drug research at this speed and at this scale. So they're able to hit 42 days when they got to their phase 1 trials. They got 11 months to approval. So what used to take 10 years, they got done in 11 months. Well, why? Because they could experiment. They were able to scale up their compute. They had this thing called the Design Studio, where they looked at different chemicals and different tests and different combinations to try to find the capabilities. Greg, interesting point. Some of it has been approved. mRNA was not net new invented in the year 2020, but it certainly had to get approved for this usage. As we know, COVID is a variant of SARS and MERS and some of the other things. So there's certainly parts of it, but even in prior years, for the whole 10-year duration, some of those drugs had already been approved before as well. So certainly an interesting point you raise, but nonetheless, 11 months to approval is kind of a record in this space. They got 600 million doses out, and they had 100 million earlier in this year. So still interesting how they're able to experiment fast, be agile because of cloud. Another couple examples here. This is an article from the CIO of John Deere, and you may know John Deere is an agricultural company feeding a hungry planet. And there's two parts of this article, and obviously I'm not going to read it all, but there's two parts that really struck me. The first is they want to try to build they want to manage every plant. And by plant, we mean corn stalk, soybean, go down the list. They're trying to having a one-to-one relationship with every single plant, because guess what? Each plant had a certain depth, an angle, a down pressure, all these other characteristics of it, how much herbicide, how much light, all these other characteristics. They want to have a relationship with each plant. Just think about those numbers. Just think about how many seeds are planted by John Deere equipment every year. Trillions? Just a stunning number. Things that are enabled, and it may not work. It may increase yield, it may not, but nonetheless, you can try these things in cloud because the cost isn't the same. The second point on here was They're putting computer vision. So this conference is about analytics. They're putting computer vision on the back of their herbicide sprayers to differentiate between weed and plant. And so they are selectively spraying just weeds. And as a result, they've eliminated up to 90% of the herbicide sprayed, which means the farmers are paying 90% less. 90% less goes into our environment. And I'm not getting nasty herbicides sprayed on my food. Big fan of that. And this is enabled by analytics. This is enabled by AI, ML, computer vision. Okay, next poll question. So which one do you like? What's your favorite? I want to see how many Traeger people are there versus Big Green Egg versus Weber. And I hope Timothy Brown out of Atlanta, Big Green Egg is Atlanta. So which are you? I want to hear who's Traeger versus Big Green Egg versus just the good old Weber. I'm an egg person. I'm not trying to sway the vote. Anyone? Oh, Donna's like the egg. Yep. Oh, we got some Traeger. We got some Weber, some more eggs. Weber all the way. I'd argue you haven't had an egg. Eggs are awesome. Good old charbroil. Okay. Simple Weber. Okay. So another article, another use case is Traeger. And as many of you know, the grills aren't the grills that we used to have. The grills have a lot of capabilities. They have a lot of IoT, a lot of data that comes out of them. And so their call center would get inundated with calls about what's the right temperature, why isn't it working? Do you have recipes, tips and tricks? And so they now implemented this year analytics. So historically, there was up to 1,300 potential questions and paths, 1,300 that the call center rep could go through. And each of those could have 4 or 5 or 6 different levels of question and answer. Now, because of analytics and machine learning, when someone calls in, they are able to predict with 95% accuracy of what the question is going to be, route it faster, maybe answer it directly online or directly in the call center, and get people back to grilling and eating, which I'm a big fan of both. They've been able to reduce their average handle time by 15% and increase customer satisfaction as well, all via analytics, all the interesting data that comes out of these devices. See, I love the eggers. I'm sorry, I'm such a fan. I egged last night. It's a big moment. Next, okay, what's the biggest challenge facing the NFL? Put this in the chat as well. What do we think the biggest challenge is facing the NFL right now? Guesses on the biggest challenge. And the answer of getting the Falcons to keep winning, that's another trick. COVID, okay, good one. Injuries, okay, brain injuries. Now player safety, concussions, now you're on it. Yep. So concussions are obviously not enough good quarterbacks. Yeah, I got that for sure. Concussions is probably the biggest existential threat to NFL, not only player safety now, but how many kids are not playing. And if the kids stop playing, then obviously that's an issue for the NFL in general. So they have done an immense amount of study using AML against video. So they went back and analyzed, I think it was 10 years of video to find the plays, the angles, a whole bunch of characteristics about the plays that resulted in concussions. If concussions was the outcome, what is the various things that happened by looking at video after video after video after video to identify it. We also know that a concussion isn't necessarily one play. It may have been 4 or 5 plays prior to the person going out. So they've made a significant, youth pipeline, exactly, with concussion concerns. So they've made an immense study, and as a result, one of the biggest changes they made was changes in helmets. Some may know that not all the players were happy with that, but biggest changes were helmets. And as a result, they have dropped concussion rates 24% in 2 years. 24%. So that's making chill difference not only in the NFL, but also the youth players as well. So it makes a difference for sure. Last story I'll bring, and this is one of my favorites, is this is Intuit. And this little image it's a shoebox person. And my wife was an accountant. And if you look at this image, there's a term called shoebox people in the accounting industry, where come tax season, some small business owner walks in with a shoebox of receipts and just dumps them on the accountant's table and say, here you go. And the accountant's trying to make sense of all these receipts. Well, guess what? Intuit, sound like your old boss? Me? Well, maybe, again, my wife went through this directly with the whole shoebox problem. Intuit is using AIML to read all the receipts, categorize the receipts, which is always a challenge. Is this a business expense? Is it a personal expense, especially for small business owners? And they, oh, in a good way. Okay, that's good to hear. I mean, your old boss means you quit for a reason, so I was getting a little afraid there, Lauren. But interesting stats about Intuit as well. And when you think about tax filings, there are 80,000 pages of tax law, 80,000 pages, and it changes almost every year. So Intuit's using AIML to go through the 80,000 pages and try to maximize the deductions that every single person can take by matching up the two using AIML at scale. Because otherwise, you used to have an army of accountants who had to read the 80,000 every year and apply them to each of the filings to try to get the maximum deduction. So this is another case where AIML is making a direct impact on our customers in our world. So those are some of the use cases that I believe are best enabled by analytics. So Amazon, and Amelia asked me to kind of give a quick overview of how Amazon is helping AIML. So as many of you may know, let's just see a little, who's using any Amazon products and services right now in your job today? Just quick poll. Give a +1 if you're using any of the Amazon products right now. Oh, I see. Ask a question. If it's agenda, got it. Okay, so we certainly have some. Rita, thank you for the answer. Garrett. So we have a pretty strong list of capabilities. You'll hear more tomorrow. As you might imagine, Amazon themselves uses AML extensively. Use Skynet. Wow, great Terminator reference. I don't get enough Terminator references at 9:30 in the morning. Nicely played. So lots of use cases for analytics and machine learning by industry, marketing, customer 360. You see much there. What's really helping, and this kind of gets back to the Novartis case, is that many of us remember in the not too distant past is let me get a big massive system on-prem and another big massive system on-prem, and we couldn't grow them, we couldn't scale them, we couldn't integrate between them. It was always a big challenge to get data together. Now we can put data in one big place, a data lake, a data warehouse, a lot of terms of that. There's even open formats. Some may use these open formats like Parquet, Avro, ORC. And the point of that is that it liberates our data for any analytic, for any open source. You're not limited. So there's these capabilities that are really, we hear democratization and all these other things that are really making analytics available at scale to the masses. There's a pretty decent, there's a solid stack solid stack of capabilities between analytics and machine learning. So we certainly within the data analytics stack, we have AWS has a long list of capabilities between data warehousing, visualization, search, streaming, many capabilities there. Then on the data scientist side, we have a service called SageMaker, which is basically managed Jupyter notebooks. I suspect many put a +1 if you use Jupyter notebooks. I suspect a lot of you use Jupyter notebooks, maybe Python, things of that nature. So it takes the Jupyter notebook and just manages it for you. It makes it easy. It makes it easy to scale. We've put a lot of capabilities in it. Yeah, there's Dennis using Jupyter notebooks, of course. There you go. Yep, a lot of usage of Jupyter notebooks. So we're managing them. We're adding a lot of capabilities therein. Autopilot to pick models for you. Ground truth is an interesting capability to where we're crowdsourcing image recognition that this is a chair or that's a coffee mug at scale. Oh, is Timothy Brown really your old boss? Oh my gosh, we got a little thing going on here. I was not expecting this kind of thing in chat. Love it. So a couple of final items. I know there's just a few minutes left. We're also trying to make AML available to wider users. We're trying to make it a capability that business analysts can use themselves. So We have SageMaker Studio to make a nice user interface for end users. We also have embedded it in our visualization tool. So QuickSight is our visualization tool, and we have SageMaker models directly available in there. We have predictions in there and other capabilities to bring these models to the masses. And then finally, we're integrating ML directly in our data warehousing service. So SQL that many of us have used for years and will probably be used for years to come. Let me be able to train and execute models directly from a SQL interface to democratize it even more, to make it easier to use at scale for thousands and thousands of use cases for sure. Here's a quick list of resources that you can use. Clearly, you can go to the AWS website. We have lots of videos, many events in the local area, lots of virtual events as well. So here's a quick list, but of course, you can go out to our websites and find more. So finally, I don't remember what your dog's name is, but your dog is a believer in data and analytics. And I think your dog is the one that is going to think big and experiment more. So the call at the end, experiment boldly, think big. We want to hear about some more failures because then guess what? That generates more successes. So thank you for your time. I'm looking if there's any questions here. Yeah, it's a data dog. There you go. It's our first data dog. I'm just seeing if there's any other questions. So no more time. So thank you for your attention and enjoy the conference. Thank you.